We're solving problem 9 from the Spring 2021 MC12B. We want to find what this difference of logarithms is. First thing we want to do in this problem is get rid of the denominators. So we know by logarithm properties that, say, for this term, log base 40 of 2 is equal to 1 over log base 2 of 40. So basically we're taking the reciprocal. So when we take the reciprocal of a denominator, it just gets rid of the fraction. So then this whole thing just becomes log base 2 of 80 times log base 2 of 40 minus, we do the same thing here, log base 2 of 160 times log base 2 of 20. We can then split these really two things up. These logarithms simplified, So we get that log. So we see that all of these can be one way or another made into log base 2 of 20. So we want to obtain log base 2 of 20 for each one. So for log base 2 of 80, this is going to be 2 of 4 plus log base 2 of 20. We see that we have log base 2 of 20 in this one, and then this just cancels out to 2. And then this becomes log base 2 of 2 plus log base 2 of 20. This cancels to 1. And then you subtract 160 is 8 and 20. So you do log base 2 of 8 plus log base 2 of 20. This becomes 3. And then this log base 2 of 20, you just multiply that there. Now, in this case, you can just multiply everything out. The way I like to think about it is you think of these logarithms as like variables in an equation in like algebra. So this would be 2 plus 2 log base 2 of 20 plus another one, log base 2 of 20 times 1 is log base 2 of 20. And then you add log base 2 of 20 squared. That's why we wanted the like terms for the logarithms. This becomes 3, and then the subtraction side is minus 3 log base 2 of 20. And then you have to also subtract log base 2 of 20 squared. So all these logarithm terms end up canceling each other out, except for this 2. So you get that our answer for this problem is simply 2 for this difference in logarithms.